All right, hi guys, welcome to Station 2. This is where we're just practicing the idea of isosceles triangles and working with equilateral triangles and equiangular triangles. But just remember one thing you got to know for the test. You're going to have to know the different parts of an isosceles triangle. So remember, our two sides that are congruent are going to be called the legs. We have our base down here. Our two congruent angles, which are opposite our legs, are called the base angles. And then we also would have our vertex angle. So please don't forget that, but also remember if two angles are congruent, you have two sides that are congruent. If two sides are congruent, two angles are congruent. And we also learned that if I have an equilateral triangle, I can automatically assume that it's equiangular, and if it's equiangular, I can automatically assume that's equilateral. So let's go ahead and go with these first parts here. It says complete each statement and explain why it's true. So look at the first one. It says angle DBC is congruent to what? Which is congruent to angle CDB. Well, notice I have three congruent sides here on this triangle, which makes it equilateral. And if it's equilateral, what do I know about my angles? They're equal because it's equiangular. So my answer for that would be angle BCD. Why? If you have an equilateral triangle, then you have an equiangular triangle. So all the angles would be congruent. All right, the next one, they go angle BED. So this is our angle right here. BED is congruent to what? So if I go BED, well, I'm going to tell you right away, it's a base angle for triangle BED. So that means my other angle it's congruent to is going to be angle BDE. Why? The base angles of an isosceles triangle are what? Or you can say if two sides of a triangle are congruent, the angles opposite them are congruent. So you can keep that in mind. All right, now let's look at the next one. It says angle FED is congruent to what? And as DFE. So we have a break here. We have angle FED, angle DFE. I don't know how you say it that way. So I know these two are going to be on with these two over here. And so, oh look, what type of triangle is that? Oh, it's equilateral, so I know it's also equiangular. So again, my angle for that one would be the one that's missing right here, angle FDE. Again, if it's an equilateral triangle, then it's an equiangular triangle. Okay? All right, last but not least, AB is congruent to what? It's congruent to BE. Now there's three of them. So looking at this, I'm sure there's no surprise. Oh look, it's an equiangular triangle. If it's an equiangular triangle, what do I know about all my sides? The sides are going to be the same, exactly. So that means I should also have the fact that segment AE be included with this. And remember, if equiangular triangle, then it's also an equilateral triangle. So an easy way of explaining that. All right, now the next ones, even though I know they're going to be fairly simple for a lot of you, I want to make sure that you are showing your work. Remember, I have to see your thought process with this one. So I'm just going to ask you to solve for the missing variables using what we know about isosceles triangles and equiangular triangles. Please don't forget simple things like the angles of a triangle add up to 180 degrees or that you need linear pairs. So first things first here, I look at this and I realize it is exactly what it says, an isosceles triangle. But I know the base angles are congruent. So I know really that's x degrees. And then, you know, that moment of, oh, happens because I realize, oh, look, I have a linear pair. So to solve for x, all I have to do, I'm going to use this one back here, I have to go 180 minus 115. Oh, that's 65 degrees. So x is 65. So this angle is 65 and that angle is 65. Oh wait, now I know two out of the three angles. So to solve for y, I'm just going to go 180 minus, what would 65 plus 65? Oh, that's 130. Y is going to be 50 degrees. So I get x is 65 and y is 50. Pretty quick and simple problems to do. If you look at number 6, it's doing the same type of idea. Except for now I'm going to use the linear pair going this way. If that's the case, I know that's 45 degrees. I like how my pen just rolled all the way across there. Good distraction, right? So if this one's 45, what's x going to be? Oh, that's going to have to be 45 because, again, the base angles of an isosceles triangle are congruent. Well, what did those two add up to? 90. So that means y is just 180 minus 90, which is 90 degrees, which means it's going to be an isosceles triangle. And most of you are going to be in the habit, if you see two 45-degree angles, you're going to automatically learn, you just assume the other angle is going to be 90. All right, and then we look at number 7. And I'm like, okay, look for y and x. They're part of angles. And by the way, this is what the angle x is really supposed to be pointing to, not a side. So when I look at that, I'm like, oh, it's equilateral. Well, what do I know from up above? It says equilateral triangles imply equiangular triangles, which means then, see if I can get that same color here. All these angles are exactly the same, which means they're equiangular. And if it's equiangular, that means that's 180 divided by 3, that's 60 degrees. So I know this is 60 degrees, this one's 60 degrees, and this angle is 60 degrees. So now I can just do quick show of my work. I get y to be 70 degrees, then I get x plus 5 equals 60, and then I get x is equal to 55 degrees. That's it. Not meant to be difficult. Okay, let's look at number 8. All right, with these, I have an equilateral triangle, so I know it's equiangular. So I know that's all true. And what did we know we just talked about in step 7? Well, they're all 60 degrees. So I know this would be 60 degrees, this one would be 60 degrees, that one would be 60 degrees. So I can solve for the missing stuff real easy. 3y is equal to 60. Well, okay, so y equals 20 degrees. 2x is equal to 60. Well, what's x? Equal to 30 degrees. All right, let's look at number 9. On number 9, if you notice, I've got a perpendicular segment from the vertex angle, but they didn't say it was bisected, so I can't assume that. But it's a good chance if it's perpendicular. Would it be the case, guys? You're right, it would bisect it. So I'm looking at, I'm like, okay, how do I make this easy? Well, I'm going to make this easy by using my linear pair. Okay, when I have a linear pair, I know they add up to 180. So I can go x is 180 minus 110. This is going to be 70 degrees. Right? All right, if that's 70 degrees, I'm going to use the fact of this smaller triangle right here. And I know two of the angles. I know one's 70 degrees, I know one's 90 degrees, but I'm actually going to use it quicker. I know the acute angles of a right triangle are always complementary. So if I go here for y, I'm just going to go 90 minus 70, and it's going to be 20 degrees. All right, on the next ones, it is going to be so fast because you're going to see how simple this is. First of all, would you guys agree with me with that reflexive property? Those are two congruent triangles. Side, 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 right? Well, if that's the case, I should know right away what x and y both are. Because look at this triangle. Is that an isosceles right triangle? If that's the case, I know my two angles plus 90 are going to add up to 180. Well, if we notice from earlier, y is going to be 45 degrees. That's a very logical assumption. Well, if y is 45, guess what x is going to have to be? Because the triangles are congruent and corresponding parts of congruent triangles are congruent. They're both 45. Okay, now let's look at the next one. All right, it says use the properties of an isosceles and equilateral triangle to find the measure of the indicated angle. I want to know the measure of angle ACB. So this one right here. This is what I'm looking for. That's why I'm using the arrows. How am I going to do that? Well, I'm going to use the fact, a lot of things, okay? I'm going to use the fact that the base angles of an isosceles triangle are congruent. So I know this angle is also 45. Once I do that, I know ACD and angle ACB are going to be a linear pair. So all I have to do to find the measure of angle ACB, just go 180 minus 45, and that's going to end up being 135 degrees. Now, let's look at the next one. Angle DBC. Okay, well, if I have angle DBC here, I actually know that these two are going to end up being congruent to each other. So when I do that, I go, okay, that means this one's 70. Oh, look. Now I can solve for my missing angle. So I'm just going to go, measure of angle DBC is going to be 180 minus 90 plus 70, or you could go 90 minus 70. The same thing is going to happen here. And you're going to notice it's going to equal 20 degrees. Not too difficult for us to do. All right, let's look at the next one. I want to know the measure of angle ABC. I want to know this angle right here. Well, I'm going to use some things to my advantage here. I know that these two angles are going to be congruent by the vertical angle theorem. So if I know this one's 55, I know that angle is 55. Well, 55 plus 55 is 110. What does that leave? That leaves that to be 70 degrees. Oh, look, this is 70 degrees. What's left for the two base angles that need to be congruent to each other? 110, right? So the measure of angle ABC is just 110 minus 2. Oh, that's 55 degrees. So the measure of angle ABC is 55. So just marking up our diagrams help us get that. All right, let's get the last problem on here. It says equilateral triangle ABC and isosceles triangle DBC share side BC. If the measure of angle BDC equals 34 and BD is equal in length to BC, what is the measure of angle ABD? Hint, it may help to draw the figure described. Hello, visual people. Is that a hint we need to even use? So let's do this first. I'm going to draw my equilateral triangle first. It's a little bit easier for me to draw. So I got A, B, C. Now they said this is an equilateral triangle. These are shared. Then it says we have DBC, so we have an isosceles one, so we know that's true. And we know that BD and BC are congruent. So we know that is true. Are you guys with me on that? And they also say the measure of angle BDC is 34 degrees. You go, what's the measure of angle ABD? So I want to know the measure of the whole big angle. Well, if this one's 34, this one right here is what? 34. Why? Because the base angles of an isosceles triangle are congruent. So that adds up to 68. So I know the measure of angle CBD, I'm going to change pens here, it's going to be 180 minus 68. Well, what's that going to be? Well, it's about 100, did I get that right? 112? I think so. Okay. Now, so that's 112 degrees. Boy, did I not draw that accurate at all. So, it's still the basic idea, so we can get it there. All right. So that's 112 degrees right here. Now, what do I know about triangle ABC? Well, it's equilateral, and all equilateral triangles are what? Equiangular. So I know all these are the same. Well, that's 60 degrees for all of those. But I'm looking for this angle. Well, the measure of angle ABD is the sum of the parts equal the whole. So it's 60 plus 112. Oh, that's going to be 172 degrees. Now, that's huge, but hey, it does work. Not drawn accurately, but we should be able to get it. All right, we're going to be done now, guys, for this. Now, if you have not done Station 1, you need to go now to do Station 1. Awesome. Have a good day, guys.